Hello, we got cut off at the end of, I cut you off. I pushed the wrong button at the end of last lecture. I was finishing up talking about the production possibilities frontier and economic growth. And we're talking about that going back to 1900, economists who study economic growth have determined that, going back again over 100 years, about 1/3 of our economic growth has been due to having more population, either internally or through immigration. 1/3 of our growth has come through investment in capital, both physical and human capital. And then 1/3 of our economic growth has come from improvements in technology. And then last thing to talk about is the term capital depreciation. Capital depreciation is the wear and tear of capital. Capital wears away, breaks, or becomes obsolete and has to be replaced. And what happens with capital depreciation if we do not replace it, then we have a shrinking economy right here. So we would go from production possibilities curve 1, which is out to the right, and we actually move in to the left with production possibilities frontier number 2. And that's not good. That means we have a shrinking economy. That means that living standards are falling, and that is, again, not a very good situation. So what we need to have investment to beat the minimum, at least greater than, or again, at the minimum, equal to the amount of depreciation. If it's equal, then we can maintain our same position. If we have a greater than depreciation, we can actually move it out. But this situation here would be where it's going to be investment is actually less than depreciation. So we actually have more capital wearing away, breaking, becoming obsolete than the amount we're building right now. And so this situation right here would be represented by this diagram here. Now, let's start chapter 4 lecture on trade. And here we will apply the production possibilities frontier. Not in this lecture, but in the next one. Trade, we look at the gains from trade. And economists have studied trade quite a bit, and we've determined that trading between economic agents, individuals, cities, states, nations, benefits all parties. And there's 2 kinds of advantages in trade. One is known as absolute advantage, and the other one is comparative advantage. And for a long time, economists, politicians thought that, people in business, thought that absolute advantage is what determines the benefits of trade. And it turns out a guy named David Ricardo, an early economist who lived during this time period, he came up with the idea that no, trade actually is determined by comparative advantage. So 2 terms to know for this class. One is absolute advantage. I expect you to know what this term is, and it means you produce more of a good or service with the same amount of resources. Comparative advantage, we're going to use more. We're simply going to look at absolute advantage, figure out who has it, and then not use it any further because this does not determine the benefits of trade. With comparative advantage, it means you can produce a good or service at a lower, a little typo there, at a lower opportunity cost. So let me explain this by having an example. And this is the kind of question I would ask on exams. So here I made up some numbers for 2 different countries. Whoops, I didn't change that. Let's go to Lilliput. And let's go to Fredonia. So one worker in Lilliput can produce either 2 computers or 10 tables. Where do these numbers come from? I made them up. One worker in Fredonia can produce 30 computers or 15 tables. Again, I made these numbers up. And that's what I would do on the exam. I would make these numbers up. And so the first question I would ask you, who has an absolute advantage in computers? Would it be Lilliput or Fredonia? And so you look at the production of computers, and we have 2 computers in Lilliput. We have 30 in Fredonia, so the answer is Fredonia. Fredonia is a yes. And to explain that, you simply say they can produce 30 computers, which is a lot more than the 2 computers in Lilliput. And that's good. And then next question, who has an absolute advantage in tables? And going back to the numbers, the answer again is Freedonia. They have a yes. And so it's a no here, and it's a no there. And to explain it, you would say that in Freedonia, they can produce 15 tables, which is 5 more than the tables in Lilliput. Now, I on purpose made it so Freedonia has the absolute advantage in both products to show you that it's not relevant in terms of trade. What matters for trade is down here in the opportunity cost of producing one computer, or one table, because we want to show comparative advantage. And the way to show comparative advantage is to show who has a lower opportunity cost. So what I would ask on the exam, based on the numbers at the top there, who has a comparative advantage, and to show that you have to answer these 4 questions here. So what is the cost of producing one computer in Lilliput? And the answer is not up there because we have 2 computers, not 1. So I do know the cost of 2 computers. I'm going to write 2C. C stands for computers. And so 2 computers has a cost equal to 10 tables. And I'll use a T for tables. Now, I want to get it down to 1 computer. Can I get 2 down to 1? Yes, I can. If I divide 2 by itself, that leaves me my 1 computer. I've got to divide on the other side by the same 2 to keep this equality sign intact. And so 10 divided by 2 gives me 5 tables. So now I have the cost of producing 1 computer in Lilliput. The cost is 5 tables. Every time you make 1 computer, we give up 5 tables, which stands to reason because that's the same proportion as 2 to 10. Do the same thing for Freedonia. I don't know the cost of 1 computer, or I do know the cost of 30. This or up here tells us the cost. It's one or the other. So it's either 2 computers or 10 tables, or it's 30 computers or 15 tables, not both. So if you want to produce 30 computers, it's going to be the cost of 15 tables because that worker cannot do 2 things at the same time. It's one or the other. I want to get it down to 1 so I can compare it to Lilliput. So again, mathematically, I get the 30 down to 1, divide by itself. That's my 1 computer. I divide 15 by 30 to keep the equality sign intact, and that's 1/2 table. And proportionally, 30 is twice 15. 1 is twice 1/2. And so proportionally, they are the same. We couldn't compare the numbers at the top there in terms of who has a lower opportunity cost, but we can down here. So every time I make a computer in Lilliput, we give up 5 tables. Every time we make a computer in Freedonia, we give up 1/2 table. And so down here, we can answer the question, who has a comparative advantage in computers, and that is going to be Freedonia. And I'll write that down there in just a minute. Now, one thing about comparative advantage is that it's mathematically impossible to have the comparative advantage in both products. We can have the absolute advantage in both products, which I've just shown with Freedonia, but that's not the case with the comparative advantage. So I know for a fact right now that poor small Lilliput, who has no absolute advantage, does have a comparative advantage, and that will be in tables. And to show that, let's do the math. Let's do the numbers. And so I want the cost of 1 table. I got 10 tables up there, so I know the cost of making 10 tables is 2 computers. I want to get it down to 1 so I can compare it with the Freedonia. So I divide 10 by itself. I divide 2 by 10. And that gives me 1 table has a cost equal to 1/5 computer. You can write it as 1/5 or 0.2. 1/5 is 20%. So every time I make a table in Lilliput, they give up 20%, 1/5 of a computer. Do the same thing for Freedonia. I know the cost of making 15 tables that was given to us is 30 computers. And I want to get it down to 1 so I can compare it with Lilliput. I divide 15 by itself, 30 by 15. 15 divided by 15 is my 1 table. And then 30 divided by 15 is 2. So every time I make a table in Freedonia, we give up 2 computers. So poor, again, Lilliput, who has no absolute advantage, does have the comparative advantage in table production. So moving up here, we now can say who has the comparative advantage in computers. We're going to say Freedonia. Because they can produce one computer at a lower cost, and that cost is 1/2 table. Then in Lilliput, where the cost is five tables. 5 tables. And over here you do the same thing. You would say it is Lilliput. And then simply compare the cost. You would say the cost there is 1/5 computer, which is less than the cost in Fredonia, which is 2 computers. Now I'll end there, and I'll come back to review this in the next lecture, but I want to give you a problem to work on before we get to the next lecture. And so these are questions you would expect on the exam. So you can go ahead and take a picture of this if you want to. Or you can pause the video, but I have 2 countries here. I have Slovenia on the left side, who can produce, one worker can produce 8 computers or 2 tables. And on the right side, we have Latveria, where one worker can produce either 10 computers or 20 tables. And your job is to determine the absolute advantage in both those, and then figure out the opportunity cost of making 1 computer and 1 table in both countries, and then down at the bottom, determine who has the comparative advantage of computers and who has the comparative advantage of tables. And I'll see you at the next lecture.